This video is an introduction to an upper mantle flow hypothesis. Directly measuring flow in the upper mantle is not possible using available technologies. The mantle is not accessible because it lies under the Earth's crust, which eliminates direct methods of detection. The upper mantle magma moves very slowly due to the high viscosity of the material. This makes it impossible to use Doppler shift techniques to identify fine details of magma movement. This hypothesis proposes that Earth's upper mantle is divided into separate east to west bands of magma flow. These bands move in alternating and opposing directions. Finding evidence of these mantle flow bands would require discrete surface indications. Some possible examples of the influences of mantle flow bands, which will be covered during this video, include mid-ocean fracture zones, the rates of slab subduction, and the formation of mantle hotspots. The first potential example of the influence of these mantle flow bands on the surface geology are mid-ocean fracture zones, which are well represented in the eastern Pacific plate. Magnetic anomalies can be found between the eastern Pacific fracture zones. These are north to south magnetically polarized strips of crust which have been fixed throughout Earth's pole shift history. A magnetic anomaly within a fracture zone is often laterally offset from the anomaly positions in the adjacent fracture zones. The pattern of these offsets alternate in the same pattern that the mantle flow hypothesis would predict. The eastern Pacific plate contains very few large seamounts or oceanic plateaus, which would result in a lower structural strength compared to regions of crust which contain this additional material. The thin crust of the eastern Pacific plate could make it more susceptible to being fractured due to underlying forces. The East Pacific fracture zones generally run in east to west orientations and have relatively even spacing between each zone. The structure and spatial orientation of these fractures could indicate the effects of underlying mantle flow. Where the East Pacific fractures meet the subduction zones along the North American and South American plate boundaries, there is additional potential evidence for the surface effects of these mantle flow bands. The subduction zones occur at shallow or steep angles between the Pacific fracture zones. These shallow or steep subduction zones tend to alternate along the western edge of the American plate boundaries. Looking at an example of shallow subduction, a possible force which would slow the plate subduction could be a mantle flow proceeding in the same direction as the plate subduction. If a plate is subducting in an opposite direction of the underlying mantle flow, the possible force on the plate would speed the subduction of the plate, thus increasing the angle of subduction. The final possible indirect evidence that will be touched on in this video is the possible link between mantle flow bands and the development of mantle hotspots. Since this hypothesis proposes that bands of moving mantle flow past each other in opposite directions, there will always be a region of turbulence where these bands meet. In some cases, the regions of turbulence could generate rotational vortices. In rare cases, conditions could be right to drive an exceptionally strong vortex, which would have sufficient energy to draw a deeper mantle into the rotating magma. The decreasing viscosity and increasing pressure of the newly involved magma would further increase the rotational and vertical flow of the upper mantle vortex. In very rare cases, the vortices could accumulate sufficient energy to involve even the deepest regions of the mantle. Once a direct pathway between the deep mantle and the upper mantle was established, the higher heat, lower viscosity, and higher pressure of the lower mantle material should maintain this vertical flow channel on a geological timescale. If the mantle flow bands hypothesized in this video exist, they are only one of the processes acting within plate tectonics. It may be difficult to separate the effects of multiple geological forces when they are acting in the same region. There are additional examples of the possible influences of mantle flow bands to be considered in another time. Thank you for considering this upper mantle flow hypothesis. Your comments are welcome. The images in this video are intended for the illustration of concepts and may or may not represent actual geographic locations or geological systems.